All right, it's week 10. It's the end of summer, which I know is sort of bittersweet. Summer's almost over, but you get to go see your friends again, and you get to go, learn again. Yay! All right, hopefully you've gotten a lot out of this summer, and if nothing else, you know you're ahead of your friends, and that's got to feel good, right? Let's go into week 10 with a vengeance. We're going to talk about the last of the parent functions I think that you're going to be focused on next year. There may be one or two others that creep in, but we've talked parent functions so far, and here's two. Unfortunately, they are mean parents, and you're about to see why. What's mean about them is that there are four of them, four parent functions, and they all kind of look the same. The general shape's the same, they just face different ways. So what we're going to do is talk exponential growth versus exponential decay. So the idea here would be that the parent function for these two is always y equals some number raised to the x power. Okay. Now the b is going to tell you everything about these two. If the b is greater than 1, then the graph's going to look a certain way. And if the b is between 0 and 1, then the graph's going to look a completely different way. I wonder why there's a delay on my pen. It's kind of freaking me out a little bit. Let me try that. Okay, so what do they look like? Well, if the b is bigger than 1 on an exponential growth, it's going to look a little something like this. And these are little arrowheads here. And these also have an asymptote here. I know we've kind of mentioned asymptotes before. It's that invisible line that you are getting really close to, but you'll never actually touch it or you'll never actually cross it. Now, an exponential decay has the same kind of shape, except it goes down. Because if you're decaying, then you're decreasing. And that's what it's going to look like. And we're going to have the dashed asymptote here as well, okay? So that's kind of how those parent functions look. Now, a logarithmic growth and decay, the thing with logarithmic, since we studied those last week, remember how there was a relationship to exponential? There's actually an inverse relationship, and the equation for these is always log base b of x, so it looks something like that. But it's the same thing where if the b is bigger than 1, it's going to look different than if the b is less than 1. And the way that those look is like the following. And I'm going to see, once I sketch this, if you can compare in the chart maybe what's happened and why they look different, okay? So this one has a vertical asymptote, and a logarithmic growth looks more like that. This one also has a vertical asymptote, but a logarithmic decay looks kind of like that. Okay, so see why these are mean? They all look like the same exact curve. It's just put in a different place, and the asymptotes are in a different place. So these are your four last mean parents, and notice that the way I used to memorize it, even right now when I sketched them for you, the way I memorized it is I know this one very well, and this one is just the inverse of this one. So all that I did was I imagined, and don't write this on your paper, but I imagined if there was the diagonal line y equals x, then I imagined flipping this across the red line, and what would it look like? So that's the relationship between this one, and between this one and this one. It's just flipping it across that red line, okay? And I know it's hard to see, but I promise it works if you do it, okay? But more about inverses later or when you get to school, okay? So don't worry too much about that if you don't know that word that I keep throwing out there, okay? But these are the four. If you want to commit them to memory, that's great. What that means is that the parent function might always be different because the b could change for any problem. The b could be a 2 or a 3 or a 4, and what you would do is it would change the steepness of this, okay? So same thing here. If the base was a 2, 3, 4, it would change how steep this thing is, and that's going to come with experience, and we'll do a few examples here, okay? All right, now We're going to do the generic transformation form. Earlier this summer we had a video where I showed you a parent function and I kept inserting like if there was this, if there's this, if there's that, and we talked about what all that stuff meant. This is going to be the same thing. So on a problem like this you'll have, y equals, okay, somewhere in the problem you'll have a b to the x, okay, and I'm going to put that in parentheses. All around that parent function stuff can happen. There could be a negative here. There could be a vertical dilation there. There could be a number in the front. There could be something up here, and there could be something out back there. All right, so these are all the things that could be there, and they do the same thing that they did earlier this summer. The negative in the front is a vertical reflection, which just means that you can flip it across the x-axis, okay? The A that's in the front, that does a vertical dilation. So a vertical dilation was the thing where it just made it skinnier or fatter. It stretched it or it shrank it, so we'll talk about that. The plus or minus C, so if there's a number up here in the exponent, it is going to move your function left or right. And if you remember correctly, left is if you see a plus, and right is if you see a minus. And then if there's a number added or subtracted at the back, that's going to be your up or down. So all of these are old, like we've done them before. You probably don't have them memorized yet. That's fine. Just rewrite them again, and we're going to practice graphing with them. Now for logarithmic, let's go ahead and write for logarithmic what you're looking for. Ooh, I wanted green. Okay, so for logarithmic, you're going to see the word log, and you will see a specific base b, and you will see an x, okay? Now, what might be there is there might be a negative in the front, there might be an a or a number in the front multiplied by it, there might be a left or right shift, and there might be an up or down shift. So the same negative A, C, D, this same stuff here is, they do the same things as this box. So I'm not going to recopy all that junk, okay? If you want to know what that does, just look over here, and we already wrote vertical dilation, okay? All right, so now to actually practice. Okay, so the first one, y is equal to 1/2 x to the first. Now, or x plus 1, sorry. So when you see that, you have to figure out which parent it is. So is this an exponential or a logarithmic? Well, I'll give you a hint. If you don't see the word log, it's not a log, okay? So it's going to be like this one above. And what I like to do is I first sort of write out what's going to happen, and then I graph it. Okay, so the first step would be to identify the parent. Identify the parent. Because we have 4 boxes above, guys. There were 4 parents at the top of this picture, so which one is it going to be? Well, the way you do that is figure out, in all this mess, what is the b to the x? Well, in this problem, the b is a 1/2. So whenever you write 1/2 to the x, we have now handled this number, and we don't have to look at that number again, okay? And as far as graphing it, if you look above, let's look above, okay? If you look for the parent 1/2 to the x, well, that number 1/2 is between 0 and 1, so it should be in your upper right box, which looks like that. So this is how we start our picture. Now, I'm drawing this so that I know what to do with this. I'm not done. This is not the final answer because there's still a transformation up here, right? Like we've only done 1/2 to the x. Now, the only thing left up here is this plus 1 that's in the exponent. So if you compare it to the box above, a plus 1 in the exponent is like the c, and the c moves something left or right. If it's a plus, it's going to move it to the left. So I know my step 2 is going to be left 1. Okay, so I need to pick this graph up and move it to the left 1 unit. Okay, so let's just say whatever that point is, we're going to move it back left 1, and then we're going to resketch it. Beautiful. That is it. That's all you have to do. Now the asymptote, if I move this asymptote left 1, it's still an asymptote. So, I mean, you could redraw it, but you don't really have to. But that's pretty much how it goes. It will be a little trickier when you're actually in algebra, but I'm just trying to give you an intro. Please remember, this is an intro. Your teacher will be a little bit pickier about exactly what points these are, but I want you to have a good understanding of just what the shape is and how to move it, okay? So let's move on to this fella, all right? Is it exponential or logarithmic? Well, I don't see the word log, so it's exponential, so I'm looking back here again. Okay, so what do? I need the parent. So the parent is the b to the x. So in this problem, what number is the base? Well, it's the 3. Now notice I didn't steal the negative with it, okay? It's only ever going to be one number that's immediately touching the exponent. If there's anything else on it, don't take it with it. It just means that if there's something else in front of it, it's an actual transformation, okay? So 3 to the x I've just handled. Let me cross that out. It's handled. Now what does 3 to the x look like? Well, if you look up above, this 3 is a b that's bigger than 1, and if it's bigger than 1, it's the picture that looks like this. So that is my first step, okay? Now that I have that, what are the other transformations in the picture? Well, there is a negative out front that we haven't dealt with, and a negative in the front does a vertical reflection, or aka an x-axis reflection. So this curve will move down here, it'll just flip below, and the asymptote is still in the same spot, okay? And now we have, at the back, a +4. Now, is that +4 part of the exponent or not? When I look at that, I'm thinking not part of the exponent because it's kind of down on the ground here. So it means it's going to be the up and down. So if it's a +4, I think it's going to be an up 4, okay? That should be in blue. Up 4. So now I'm going to take this red curve and I'm going to move it up 4. So I'm going to take this point, whatever it is, and move it up 4. But you know what else I'm going to move up 4? This asymptote. It is still part of the graph, so I need to pick it up 1, 2, 3, 4 units. I'm going to redraw my asymptote. I'm going to take this point and move it up 1, 2, 3, 4. And then I'm going to redraw that red curve. The blue graph is the final answer, okay? So somehow if you want to write the word final or something, so if you look at it later it makes sense. Same thing here, the blue one that I've done is the final. But that's how it works. Or maybe if you're on your paper at home, just make it really bold so you can see what's up, okay? All right, the last one we're going to do is a log graph. So right off the bat, I need to identify what is the parent function. Well, I see the word log, so it's going to be like this one, okay? And I need the base, okay? Now, no base is written. There is an invisible number down here. Now, if it's invisible, it's not 0, it's not 1, it is 10. I think that was said last week on a video. If not, I'm saying it now. If a base is not written, it's an invisible base 10. Okay, so this is our parent. Now, if 10 is the b, that means it's bigger than 1. So when you look above, everybody look above to those 4 parent functions at the top. Which of the 4 do I need to start with? I think it's going to be the one in the lower left. It's going to be the logarithmic growth. So it's going to look something like that, okay? So we're going to start with this general shape and then look at like what other stuff is done to it, okay? So let me look at this, okay? The next thing I see is a -1, and it's inside the parentheses. So if we look up here, that means it's the C, and the C, just like over here, controls left and right. So this one's going to go to the right 1. So my step number 2 can be right 1. So let me move this guy to the right. But guess what else moves to the right? You see that vertical asymptote? That is still part of the graph, so I need to move it to the right also. So there is my step number 2. Everybody moves right 1. And be careful, because if you have an asymptote, it'll have to move with it, okay? The last thing is this plus 3 at the back, which would be my up and down. So it's going to be up 3. Now what do I move up 3? Well, everything. Let me move this up 3. 1, 2, 3. And what about my asymptote? If I take that and move it up 3, well, I can do that if you want to do that, but it's still just going to be in the same spot, okay? And now we just recopy the red graph, and that is my final. All right, cool. So these are so hard for people that if this was kind of a hazy video or you already know that you're going to be slow at it, slow is fine. Slow is great, okay? I only am this quick because I just know my stuff, okay? And I've done it forever and ever. But the better you know your parent functions, the easier this is going to be. So those 4 pictures at the top, where are they? These are your best friends right up here. So try to memorize those general shapes. And if you want to be specific, the other thing you might want to know, all of these cross at 1. Okay, so this is actually the point 0, 1. And down below, that's actually the point 1, 0. Which is nice to know, and it makes it easier too when you sketch your parents on your homework tonight. So give the practice problems a try, and watch me if you get super stuck. You know, maybe I'll help you get unstuck, and then you can try another one on your own. But this is some good stuff, and if you can understand this, there's really not much that can stop you next year. All right, guys, we will see you at the solution video.